a quick intro about this panel, because we, as Gary said, smart utility is well known by LoRaWAN. That is globally the #1 application of LoRaWAN is in utility, water, gas mainly. So that's why we pick up this panel. And what we want to show, we want you to learn of what has been done. It's not only slideware, so we are focusing on real deployments that have been done. As it was explained in the intro by Donna, it helps a lot that LoRaWAN is recognized. It's an ITU standard, open standard, but ITU recognized. It's important. And what you should learn, the takeaway from this panel for you, you will see through 3 different examples why LoRaWAN was the technology of choice for utility, why it did work, why it makes the job. So to do that, we are working in the marketing of the LoRa Alliance with a lot of deliverable. You can see this nice map. It's not a Tokyo subway map, looks like. Nobody can understand, but that shows the diversity of use case done in utility. Again, nobody can read that, you'd get a copy, but it shows how diversity is on all what people are doing in real, the utility company, with LoRaWAN inside. So to explain that, better than myself, we built up a panel, so I will call the panelists to come and sit down. So I will call Mr. Peter Lin from Kiwi Technology, from Taiwan. Welcome, Peter, take a seat. Also, Kasai-san, so is Yoshinobu Kasai. Mr. Kasai will come on stage from Korea and help with an interpreter as well. And last but not least, coming from Australia, Tony Tilbrook from NNNCo. Okay, so that's the panel constitution for today. And I will, before I leave the floor to Peter, who will come here to present, let me do a short intro of Peter. He's today a chief consultant at Kiwi Technology in Taiwan, but he has a lot of experience on Japan, more than 30 years experience, mainly from the ICT industries. And he's been having different general manager activity at Aegis Japan, Cyberlink, VP of Corel Japan, so very experimented guy. And he will tell you everything he knows or he can about what Kiwi Technology has done for utility. So Peter, please help me to welcome Peter on stage for presentation. Thank you. Thank you.
Hi, everyone, again. Sorry. Okay. Hi, everyone, this is Peter, and I'm very sorry because I'm not a good English speaker. And yesterday night, my daughter just told me, okay, Daddy, you want to use this speech by the English? Okay, everyone will get sleepy. Oh, please, don't do that. Yeah. I think just take 10 minutes. Let me introduce my company and our utility, let everyone know. Okay, let's quickly do this. Okay, basically my company is called Kiwi Technology. We are the Taiwanese company, and also we have a branch in Japan. I think that my company's special point that we are provide end-to-end solution. We are not to the hardware only, but we also provide the network solution. I think this is a very special point for my company. And my company just want to working with the customer and we don't want to use the paper, and we just chip the gold like the paperless something. I think this is my company's special point. We want to working with the customer more closely. Okay, let's talk about today. We just want to talk about the smart, the utility like the meters. So let's check the number first. Okay, I think this is an overall picture. If we see the North America is around 30 to 40% market share, and the European is 30 to 40. Asia Pacific is very less. It's only less than 20%. I think for the APEC area is first growing for the global smart meter the penetration rate, like these 3 areas: China, Japan, and South Korea. Okay, then today we are in Japan, so we talk about Japan. Japan gas industry market is like this. We talk about the 2 areas, LNG and LPG. if you talk about LNG, I think that only 5% use the smart meter, and LPG is around the 25%. So still is not yet, I think we still have a very huge partner in this the area, use the smart meter. I think this is a very good number to showing how we can working for the target. Okay, because we are come from the Taiwan, so we talk about the Taiwan, the market size. I think this is the scope is same thing. We talk about two areas, LNG and LPG. Especially for the LPG, it's only the 1%. Only the 1% uses smart meter, so they still have the very huge market size we can improve in my country. Okay, then we talk about the challenge of the LNG, the AMI. I think like the city safety and also the human resource the shortage and hard to the measuring and manual recording. This is a challenge for this area. And I think that the next slide is we talk about the same thing. We always face the same problem and for this kind of the LPG AMI. Okay, for the technical challenge of the traditional gas meter, I think I don't want to go through the one by one because it's talk a very long time, spend a very long time. But later we, for example, like the power consumption, because the customer always use the battery, but they need to the lifespan like 10 years. Some areas 15 years. Oh, it's a challenge. It's a challenge. It's really a challenge for us. So I think this is always I talk the first the challenge for the power consumption, and for the second I will talk about networking infrastructure. It's not only talk about the communication is a stable something. Not later. It's talk about integration. When you work with the gas company, I think we talk about cloud to cloud. You need to integration with their cloud, not only your cloud. So I think this is also a challenge for the networking for we doing this kind of the traditional gas metering. Okay, and also we talk about network coverage in the city, and because you need to find a very good place to put your gateway in the best position. Otherwise, you cannot get anything. But the problem is how you can find the best position. You need to spend the money. Okay, this is the point. So I think this is for my personal view, this is the top 3 for the challenge for this kind of the gas metering. Okay, quickly, the Kiwi solution for the Japan LNG smart metering. I think that this slide is very, very easy. Usually, okay, of course you have a meter we call the smart gas metering, and you have an MCU, so you need to do something to get the data. So we put the gateway. Okay, then you put the gateway, then you talk about you need to the very, very stable the communication protocol. So we work with the IIJ. I think the IIJ today also in here, they are the communication telecom company. They provide very stable the communication protocol. So we can send the data, go to the cloud, and we also can send it to the operator, and we also do the analysis. And this is what the Kiwi do. Okay, for the Kiwi LPG smart metering, I think this is what we do in the Taiwan, because in the Taiwan, a lot of people still use this kind of LPGs. Then the problem is they always use the code. They usually use the code, but they use our technology. I think that we can calculate very detailed, and we can let the operator, when you should go to the customer to replace your LPG. I think this is one of our technology that you need, a very unique function. Okay, this is the before, after. And okay, you can see we also developed the LoRa MCU. We also prepared the SaaS like the cloud solution. So again, the Kiwi, we provide the end-to-end from the hardware to the software. Yeah. Okay, so I think when you use this wonderful LoRaWAN technology, I think that in the Taiwan case, I think that the single coverage is 100%, and we deliver the distance that reduced like 20%, And we also no need to do the manual reading. I think we save a lot of human resources, and we save this kind of reference. They can do something, some useful thing, okay? And we meet the ESG goal. Okay, I think that this is this is value for our city safety, DX, operation efficiency, and the balance. So I don't want to go through one to one. This is we just want to explain our value in the this kind of 4 area. Okay, quickly the slide, the expression. I hope everyone can understand. If you understand, we can go through the more detail. Thank you.
Thank you. Thank you. And Peter, if you had to explain in maybe 1 or 2 to 3 points why LoRaWAN was a good fit for your use case, what would you say briefly?
Oh, my use case?
Yeah, the use case. Why LoRaWAN was a good fit? Why LoRaWAN was the technology of choice in your case? What would you say briefly?
You talk about my company?
Yes.
Okay. Okay, the use case, I think that in the Taiwan, I think we work with the Taiwan #1 gas company for do the smart metering. And in the Japan, we also in the Kansai area, we work with them to do the low-time development business, do the very good the POC. So I will say the gas utility, smart utility is the very best solution for my company.
Okay, and what LoRaWAN brings to you? Why you have chosen LoRaWAN as a technology?
Okay, I think that choose the LoRaWAN is it's a save the cost. It's a save the cost. It's a get more profit for the customer, and also he can do the very long distance, the sensory. Yeah, I think this is the very one we choice. Yeah.
No, that's a good answer. So cost and range.
Yes.
And the long range capability.
Yes. Yeah. Cost and long range. I think this is a very good point.
Thank you.
Yeah.
So, thank you, Peter. Thank you. And if you have further questions, at the end, the speaker will be available at the Meet the Speaker poster at the end. So keep your question for the end, in case you have. I hope you have questions. So now let's go. It's a panel. We travel a bit from Taiwan. We'll go to Korea with a company called SGI. So I will welcome on stage Kasai-san from SGI. And we will have an interpreter to repeat briefly each of the slides in English, because Kasai-san will explain in Japanese. Okay. So please proceed. A brief intro about Kasai-san. He's been working for Samsung Electromechanics in Japan. Yep. Then he moved to Wisol, Japan. So he has a long Japanese experience. He knows this market very well. That's why he's here representing SGI. And now for 4 years, he's a branch manager for SGI Japan. So Kasai-san, the floor is yours for your presentation. And you can use the tracker. Thank you.
Okay. すみません。日本でのイベントということで、スピーカーは私日本語でやりまして、日本語から英語へのトランスレーションがちょっと準備ができてないことなので、横にいますミスターヤンの方から、英語で簡単に、ご紹介させていただきます。でですね、私ども SJI という会社の紹介なんですけども、韓国の、通信モジュールのメーカーでして、2016年から、ですね、韓国のLoRaWAN、韓国では SK テレコムが全国網を引いてますので、そちらの通信モジュールを、供給している会社です。私ども通信モジュールメーカーとしましては、LoRaWAN だけに限らず、SIGFOX などの LPWA、および Wi-Fi とか Bluetooth ですね、ホーム IoT の方にも、通信、モジュールを供給している会社でして、スライドの左の方に書いてある通り、だいたい月産今300万台ぐらいの生産をしている会社です。さらに、最近はいろんな通信規格が増えてますので、UWB とか Wi-Fi ハロー、あと電気自動車の充電用に PLC などのラインナップというのも、最近手掛けてまして、韓国内での供給をやっております。 さらにLoRaWANモジュールとしての実績としまして、黄色い、ボックスの中に書かれている通り、累計で今65万台のLoRaモジュールの出荷実績を持っています。韓国内でのユースケースとしましては、今日ご紹介するレオテックさんの水道メーターの検診サービスであったり、太陽光パネルの遠隔管理であったりですね、街灯の管理、駐車場や物流資材のトラッキング管理などですね、韓国内ではやはり SK テレコムのLoRaWANネットワーク全国網を使って幅広い分野のユースケースが出ている状況にございます。で今日ご紹介するレオテックという会社なんですけども、こちらの簡単な会社紹介ですが、レオテックという会社は、LoRaWANを使ってですね、水道検診の遠隔無線ターミナルというのを製造して、ソリューションを提供している会社です。でこちら私どもの韓国内での最大のお客様でありながら、先ほど私ども65万台無線通信モジュール出荷してまして、その中で、最大顧客と申し上げた通りですね、その中の25万台はこのレオテックさんに使っていただいている状態だということになります。でもともと水道メーターとLoRaWANの無線ターミナルを接続してLoRaWAN通信でデータを収集して送るというサービスを展開してきたんですけども、やはりマンホールとかですね、電波が不完なエリアというのが必ずございますので、その不完エリアに対する解決策として、このレオテック社はLoRaWANの P2P ですね、デバイスとデバイスの通信というのを複合的に使いまして、それでマンホールと地上の無線接続というのを成功させ、それに関わる韓国内での特許というのも取得してサービス展開をしている会社になります。ちょっとここまでの内容を簡単に英語でトランスレーションして伝えていただきます。
We are happy to share the LoRaWAN water metering solution, which is our biggest company, our biggest client, Leotech. Leotech has been deploying 250,000 KPCs on the Korean water metering solution. And they are providing from water meter device to the platform software. That means that they can provide turnkey solution to any customer in the world. In the beginning, they plan to use wire and wireless connectivity to connect their metering device and metering terminal to for data collection. But some places are hard to connect with wire connection. That is, some place is in danger for metering by person. So next step, Leotech has been taken next step to develop a peer-to-peer conversation, peer-to-peer communication way. That's the only way to developed by LoRaWAN communication. So this development has 2 patents certified by Korean intellectual property offices to each some intellectual property.
では、レオテックがやっているソリューションについてもう少し詳しくご説明いたします。で、as was と書かれているところにありますのが、従来の、水道検診のやり方ですね。左側のメーターの方から有線で、データ収集機の方に接続しまして、このデータ収集機に入っているデータを検診員が人間が取りに行かないといけないという、やり方でした。でこちらのやり方の問題点としましては、メーターから有線で接続しますので、データ収集機の方が、接続できる場所ですね、というのに、場所の設置制約性という問題がありました。 また近くに接続しなければならないということで、検視員が実際に中に入りづらい、例えば地下に置いてあるマンホール蓋を開けて入らないといけないとかですね、そういう問題があったという大きく2つの問題があったということで、設置の制約問題だったり、検診難検診地域というんですかね、という問題があったというふうに言われています。こちらの問題点を解決するために、まずレオテックが行ったこととしましては、ステップ1として、LoRaWAN の無線を使った遠隔検診というサービスを考え、接続しました。ただこのステップ1の状況ですと、メーターと、無線のターミナルっていうのはどうしても、有線で、接続されているという制約がまだ解決できていませんでして、こちらの問題をさらに解決するためにですね、ステップ2としましては、この無線ターミナル、地上のターミナルと俯瞰地域であるマンホールなどの地下のターミナルを P2P 通信でつなぐということも拡張しながらですね、メーターと通信ターミナルでゲートウェイまで全て無線でつなぐということに成功し、さらに、韓国の、水道、管理業者さんが求められる、受信成功率 99.9% という、高い成功確率を持ってですね、こちらの、無線通信が LoRaWAN を使った無線通信が、信頼できるものとしてそれで、韓国内で今25万台という大きな数字の実績を上げることに、成功している状態です。
So Leotalk has taken a traditional way instead of LoRaWAN at the first step, but they found some hard things to meter, so they need to have an improvement. So Leotalk has taken a second step by taking LoRaWAN. Leotalk developed peer-to-peer version that protocol to cover the all shadow area and set the wire free. Leotalk meter terminal is guaranteed more than 8 years lifetime as it communicates with LoRaWAN.
さらに、レオテックが提供しています無線ターミナル、水道メーターの無線ターミナルの特徴について、まとめた内容になります。まず LoRaWAN を使うことによって、低消費電力ということで、スマートメーターの寿命が8年間という長い、寿命を維持することができます。さらに、こちらの無線ターミナル、防水機能を持ちながら IP68 という高い防塵機能を持ちながらも電池交換ができるタイプになってますので、新たにデバイスの置き換えということができなくても、長らく使っていただけるということにメリットがあります。3番目といたしましては、こちらも韓国も非常に寒い国なので水道管が凍ってしまったりという問題があったりしますが、そのような水道管が凍結してしまう前にですね、凍結防止アラームという機能も備えてまして、こちらで凍結する前に、水道メーターの状況を、検診業者の方に、安全管理、として、行うことができ、非常に効率よくなって、人気を得ているという状況になります。で実際の端末としましては、左の表示にある通り、メーターで獲得しているデータがどれぐらい取れているかっていうディスプレイがある、表示器、が標準になっているんですけども、やはりディスプレイがなくてもいいような、全く電波の不感地帯に置いてあるようなもの、マンホールの下のように置いてあるようなものに関してはディスプレイがないタイプのエンドデバイスもありますし、エクステンションと書いてます、もの拡張型というものに関しましては先ほどから申し上げている、P2P 通信の専用のターミナルということになっています。で右側に書かれてます通り、このようにレオテック社はですね、LoRaWAN を使うことでまず水道メーターを設置して優先接続しなければならないという問題点、電気配線の工事というものは必要だったんですけども、その電気配線の工事を極力減らしてですね、現場の外観を損ねることがなく、 お客様から、そのような外観上の不満というのを、極限まで減らすことに成功しましたというのがまず第一の成功になるかと思います。さらにですね、このスマートメーターをいろんなところに設置してきた経験で、やはりどうしてもLoRaWAN通信ではカバーしきれない不感地帯というのがあると。その不感地帯を解決するために P2P、ピアトゥピアを導入することによってより高い無線ソリューションに成功させることができたというのが特徴になっています。
LeoTech water meter terminal has IP68 grade and it has anti-freezing alert function that gives more efficient way to manage the meter device in the winter. Yeah. And there are 3 types of devices. And first one is display type that is most used, and non-display type for the lower cost projects, and extension type for their covering shadow area. And LoRaWAN allows wireless connectivity, and LeoTech developed P2P protocol to use LoRaWAN widely available. With this solution, smart metering system provider can control in more efficient way by metering water consumption in real time.
ちょっと最後これおまけのスライドになるんですが、水道のスマートメーターですから、当然流量の確認ですねをリアルタイムに行うということはもちろんできているんですけれども、下に書かれているアディショナルパブリックメリットということでして、実際に水道は生活に欠かせないものですから、水道を使っている使ってないということを確認しながらですね、社会的弱者、独居老人とかですね、一人で暮らしている方を日本語で言いますと見守る、仕組みということで、社会的なセーフティーネットの役割も韓国で果たしているということを最後に付け加えさせていただきます。
So this solution allows to make a cooperative with control center and government office and some civil servant work area, so can give a social service for social vulnerable, like elderly people who live alone, by checking water consumption day and night. And yeah, that's the point, by cooperating with local governments. In case Japan, there are many various smart meter cases. People in life will look forward to your interesting of LeoTech solution. Any further request is welcome.
最後のスライドですけども、レオテックが韓国でなぜLoRaWANを選んでですね、水道メーターをやっているかというものに対してのまとめになりますが、やはり低消費電力ということで8年間という長い時間稼働することができる水道メーターであるということが一つ挙げられます。で2つ目ですが、こちらも韓国で SK テレコムのパブリックのネットワークがあるんですけども、お客様自治体によってはプライベートのネットワークでやりたいというお客様いますので、セキュリティが高い通信も選択ができますよという点が2つ目のメリットになります。で最後の3つ目のメリットとしましては、先ほどから申し上げてます通りLoRaWAN通信とLoRaWANの P2P ですね、これを複合的に合わせて、完全に無線で水道メーターの検診ができるというサービスを提供できることになったという点になるかと思います。はい、ちょっと今日聞き苦しいプレゼンテーションになってしまって恐縮ですが、これで韓国のレオテック社のLoRaWAN水道メーターについての説明を終わらさせていただきます。ありがとうございました。
Thank you. You want to translate? Yeah. Okay. So, thank you very much. So, just as a conclusion, because we are out of time, thank you very much for this overview. In smart water, it's a very competitive market. Number one market for LoRaWAN for sure. Sometimes we are compared to other technology like NB-IoT, for instance.
Yes.
So can you briefly, very quickly say how you differentiate, why LoRaWAN was chosen against NB-IoT. I think that's interesting for everyone to hear your opinion. Very quick.
Yes, like Mr. Kasai said, there's three reasons why our customer take a LoRaWAN. Sorry. First one is low power consumption. Yes, in case Korea water metering market, it's long life guarantee more than 8 years should be essential. So that's the required water meter market. And there are two network type in LoRaWAN. First one is public and next one is private network. Yeah, it depends on customers' budget or their scale of project. Yeah, customer have better choice between two network system. So next one is we would say called hybrid connectivity. That is Leotech have developed peer-to-peer communication way that is covering all shadow area. Yeah, it guarantees 90% of success rate on the water metering market.
Okay, thank you very much. Thank you. Thank you. So let's move a bit further to the south of Asia, to Australia. So I will call on stage Tony Tilbrook, who is the CTO, CEO of NNNCo. So NNNCo since 2019 is a LoRaWAN network operator for enterprise. They've been very active in LoRa Alliance. That's why they're here today. Tony has a lot of experience in the telecom industry, more than 25 years experience working for companies like Superloop, StarTech, not Star Trek, StarTech, sorry. As a CTO, he's an engineer, and he will explain to you what they have done with LoRaWAN in Australia. Yeah, so please, Tony.
Thanks.
Go ahead.
Thanks, Olivier. Listen, thanks everybody, and it's really wonderful to be here. I know we might run over time a little bit, so I'll be as efficient as I possibly can through this process. Just bear with me a little bit. Now, who are we? NNNCo, as mentioned by Olivier, we are 100% IoT business. We were established for the purpose of being a national operator. Now actually more like with some global presence in multiple continents, but we are designed to be an IoT operator. We're not there to deliver other types of services, which makes us very, very focused in our market. We are focused primarily on the utility space and the enterprise space, and of course that means cities and the other organisations which fit into that scope. We specifically developed a platform, which I'll go into very briefly in a minute, to allow the aggregation of data, which I think LoRaWAN enables very, very perfectly. And of course, we now have a global presence with, we're in 16 countries and in 3 continents now, and growing at an exponential rate in terms of our coverage locations. I'm not saying we've got coverage in 16 countries, but we have isolated networks in each one of those locations. And that's another one of the benefits of LoRaWAN in terms of its global infrastructure. A little bit more about us, and the thing that I wanted to highlight primarily is we built something which I think is key to the success of LoRaWAN, and we decided that it was important for us as an operator who deals with many organisations, and each organisation has many use cases. We built a data aggregation type platform which specifically allows us to deliver and develop solutions in a really cohesive, standardised data model way, and I believe that's been key to part of our success. I'm going to get into the utility space now, and NNNCo has been quite fortunate in actually servicing both power and water utilities in Australia and increasingly overseas. Some of the quick areas that we're seeing significant interest in right now is the types of solutions we're looking at for power utilities is transformer monitoring, high voltage and low voltage line fault detection, conductor down, which is an incredibly difficult and challenging thing which LoRaWAN makes itself enables very, very well. Low conductors, so where you've got sagging conductors due to heat or other conditions due to pole tilt and these types of things. Very important, particularly in the areas like Australia where one electricity line which starts to sag might touch a tree, which starts a wildfire, which causes massive problems all over the world, but particularly in places like Australia and in the United States. Pole tilt solutions, distributed energy resource management systems, the management of solar installations and how that is affecting the grid itself and being able to manage and control those, and of course safety and tracking type installations. But I'm going to focus on a couple of specific use cases because I think they have particular relevance and they're actually interesting. This is some work that we're doing in Australia at the moment with Horizon Power, which for people who don't know it, they're actually they have a very small customer base over a massive geography, 2.4 million square kilometres. They're running a distribution network out there, and many of their services actually are run on full-time petrol generators, believe it or not, over very remote locations. So for them to go out in the world and actually service some of these lines, it's incredibly expensive. So knowing where there's a fault becomes critical to their operation. So we've got this product that we have been working on for quite some time with a partner company out of Australia. And it's actually for both line monitoring, fault detection, power quality, and also conductor height. So it measures the height of the conductor above ground. It detects the actual quality of the source of the power itself. It can actually determine where there's been some sort of a phase shift between the phases which are being delivered, another incredibly important technical element for a transmission company to understand. And of course, all of this is done by harvesting the power from the line itself. So it's a Class C, it's actually, this particular device is a hybrid Class C, Class A device, but it leverages the harvesting power from the transmission line, so there's no need for a battery. It's got a little solar panel built into the device to increase coverage if the power, if the power in the line is quite low, and in some cases in remote locations that can happen quite often, and therefore provides the utility with the ability to understand the quality of the power, whether they have a line down situation or whether indeed they've got a sagging line, all in the one device and empowered all by LoRaWAN. Incredibly powerful solution. This other one here, this is a really super important issue for any power utility, and it's this conductor down problem. I don't know if anyone here is from the power utility space or has much exposure or experience in it, but just a very quick problem statement. In all transmission networks, the upstream transformers have a lot of power traversing through them, and while they're live, there's a lot of information being gathered to back at the head end system. If you get a conductor down at the upstream transformer end, you'll get a high current flow to the ground. You'll see here you've got a line sitting on the ground, that's on the load end of the service. But if it falls at the other end, you've got a high amount of current flowing, and the head end system understands there's a fault. It gets it. And it says, great, we've got a fault at this transformer, go and do something about it. But if that line down happens at the load side, in other words, downstream from the main source of power, you still get current flow because you've got backflow. It's still at 11 kV or 33 kV or 115, but the current flowing might only be 200 milliamps. That's not enough to trigger the systems at the head end, but that line is now sitting on the ground. Any person who touches it, any dog who touches it, any car that goes over it is immediately electrocuted. And there is no way to know that that system is off. Now, this is a global problem. And this partner company that we're working with today has come up with a solution on the conductor down algorithm. It uses a combination of sensors which are located at transformers, and those sensors can detect through a relationship between the sensors back in a head-end system delivered as part of the solution, which allows them to say with over 98% accuracy where there is a load side transformer fault or conductor down, and be able to deploy people out to go and rectify that before someone actually has an injury. Now, why is LoRaWAN good for this? Because again, the battery life is more significant with LoRaWAN than any other type of communications technology. It can run in Class C, so it's always available for operation. It runs a supercapacitor in the event of there being a power fault. And that allows you to keep that system up and running long enough to really be able to give meaningful information back to the head-end system. Now quickly on to the NNNCo and the water utility space. We have been very successful in this space here in Australia, and actually, again, the real reason why LoRaWAN works is we'll come up to in a minute, but some of the areas we've been working on: pulse logging for water metering where you've got retrospective builds, water metering enablement underground, again, pressure relief valve systems, very important use case for water utilities, manhole covers to determine when a manhole cover is open or shut, leak and flow, and of course environmental and water quality. I'm going to quickly scurry through these. I know, Olivier, we're running out of time. The Gold Coast City Council's been a big customer of NNNCo for a long time. Many people know that. Our success there has been primarily around the early leak detection via pulse loggers attached to existing water meters. So at a very low cost, they've been able to actually literally save millions of litres of water as a result of just being able to detect early when there is a leak going on for a particular customer. So it's been an incredibly successful rollout for them. This one here, I'm not going to go into the technical details, very happy to talk about it later on with anyone at the back, but in effect, where there's a high pressure system at one end feeding into a low pressure downstream system, imagine a big pipe pushing into little pipes. If that power isn't equalised for the downstream applications, you end up popping hot water meter systems and you run taps and you pop taps and all sorts of weird things happen. So they run these things called pressure relief valves, which are reticulated through the system, and all that we're really doing here is with a single device, 2 pressure sensors, equalising and monitoring the pressure of the system, and then informing the head end when there's a failure or a fault in that particular pressure relief valve. That enables the water utility to distribute personnel out to the site, take care of that problem before they start getting customer complaints. So I'm not going to go through all of these, but the big thing that is why LoRaWAN for utilities, is in all of those electricity use cases I mentioned before, in each case, we are harvesting the existing power from the network. You can't do that with an NB-IoT device. There's just too much power required to harvest in a non-invasive way. In other words, we're just using current transformers. So you can't do that because you need too much power to do that with an NB-IoT type device. So LoRaWAN is uniquely positioned to service something where you need to harvest energy from an external source. And of course, in the water space, we talked, couple of the other speakers talked about 8 years, 10 years. I know for a fact that these infrastructure providers, utilities, they think in decades. They don't think in 2 years, 3 years. So we have to be thinking as an industry of how we actually deliver these services with decades in mind, keeping truck rolls down, keeping operational costs down. That means we need very highly reliable and available devices, and the communications needs to be the same. I'll leave that for now. Back over to you, Olivier. Right.
Thank you, Tony. Thank you. So that concludes the utility panel. I hope everybody learned something. I hope you see a real case. So I'd like again to thank all of the panelists.